Suppose we consider task completion on a placebo versus taking some type of medicine or drug. Okay, so we want to know how long does it take to complete a certain task. Maybe you're working on an assembly line, and we want to know if taking a certain drug maybe speeds up or slows down your task completion time. So we're going to let mu1 be the mean time to complete the task for everyone when they are not on a drug. So they're going to be given a placebo. And then mu2 will be the mean time to complete a task for everybody who could be given the drug. So then mu1 minus mu2 would be the difference between the mean completion times for all people when given a placebo versus the drug. So in this case, we have the output from StatCrunch, and then I've added a little bit of information and did the arithmetic at the bottom. But the 95% confidence interval results, okay, where mu1 was the mean of the control group or the placebo group, and mu2 was the mean of the experimental group. So we're looking at the mean difference. So notice under the degrees of freedom, we've got that we're going to use 29 degrees of freedom, and that's going to give me a t critical point of 2.045 to use. So all I did was rounded the df value off to 29 since it was so close. Now when you do the difference in the y bars, you'd get what's listed under sample mean in the table, so that's your 2.29. Add and subtract your critical point, 2.045, times the standard error, the 0.94039, and I just stopped at that level. And then if you do the calculation and round it off to about the hundredths digit, you're going to get about 0.37 to 4.21 minutes for your interval. Okay, any differences between what calculation you would get and the software would just be, the software is keeping more digits in the background and doing some so the arithmetic will turn out slightly different, but usually they're going to agree pretty closely. So again, the 95% confidence interval, or CI, is 0.37 to 4.21. Now in this case, notice both endpoints, the smaller number and the larger number, are positive. So if I'm doing a subtraction of mu1 minus mu2 and I'm getting a positive number, that tells me the first value, mu1, is more than the second value, mu2. So I want that to come out in the interpretation. So with 95% confidence, I estimate the mean time to complete the task for all people who could take the placebo is 0.37 to 4.21 minutes more than the mean time to complete the task for those who could take the drug. Just a quick note, if both values in an interval were negative, that would tell you the second population mean is larger than the first by the absolute values, or just the magnitude part of the number, and you would write that in the interpretation. So you don't want to include negative numbers in interpretations. Now, just to go back and rehash the idea of what we mean when we say confidence, let's explain what 95% confidence means in terms of this particular scenario. Now remember, what we're doing is we're trying to estimate the population mean on the placebo minus the population mean on the drug in terms of time. And those are actual numbers. We don't know what they are, but they're actual numbers. So when you did the difference, right, those would be two numbers, you'd subtract them, you'd get one number, right? Let's say that that number is 1.5 minutes or something. Okay, whatever. We're going to go take samples. We're going to calculate confidence intervals for each of the different samples, and we're going to get a bunch of confidence intervals. Well, sometimes those confidence intervals are going to contain that true mean difference, okay, which maybe was 1.5 minutes. Sometimes they won't. So the confidence just says 95% of the time when you follow this process, the interval is going to capture that 1.5 or whatever, mu placebo minus mu drug turns out to be. But sometimes it's not. Okay, so explaining this gets harder and harder as we start getting more complex designs. So it might be something like this little paragraph. So if we took a large number of different independent samples of 40 people and randomly divided them, gave them the placebo or the drug, and measured times to complete the task, and then made a confidence interval for each different time we did this. Okay, 95% of all the intervals that we constructed would contain whatever the true difference of mean times to complete the task for all people using the placebo compared to using the drug would be. Okay, 5% of the time, though, the intervals would not capture that true difference in the mean completion times between the placebo and the drug groups. Okay, so hopefully that will give you a refresher on the idea of confidence and what's happening, because as you take different samples, you get different numbers, different Y bars, different S's, and those intervals are going to shift around. And sometimes they shift too far. You get unusual values that show up, okay, and it doesn't really capture what you're trying to estimate. But most of the time it does a pretty good job.